Good afternoon, students. The last class we discussed about the capacitance of single core cable, dielectric stress on a cable, most economical size of a conductor, and three-core cable, difference between the underground and overhead systems, and advantage of cables and also disadvantage of cables. Now we go for the numerical problems on cables. Today class we discuss about the problems on insulation resistance and capacitance of a single core cable. Let us go through the first problem. A single core cable has a conductor diameter of 1 centimeter and insulation thickness of 0.4 centimeter. If the specific resistance of insulation is 5 into 10 power 14 ohm per centimeter, calculate the insulation resistance for a 2 kilometer length of the cable. So let us observe the problem clearly. A single core cable has a conductor diameter of 1 centimeter. Small d is equal to, or d1, small d1 is equal to, conductor means conductor resistance is small r1, sheath resistance is small r2. So that's why conductor diameter is small d1 equal to 1 centimeter. Therefore conductor radius small r1 equal to 1 by 2, that is equal to 0.5 centimeter. And length of the cable, small l is equal to 2 kilometers, that may be converted into 2000 meters. Then resistivity of insulation, specific resistance or resistivity of insulation, rho is equal to 5 into 10 power 14 ohm per centimeter. Now 5 into 10 power 14 ohm per centimeter must be converted into ohm meter, that is equal to 5 into 10 power 12 ohm meter. Therefore the internal sheath radius, that is R2 is equal to conductor radius R1 plus the given insulation thickness. Conductor radius plus insulation thickness is nothing but inter-sheath radius R2. R2 is equal to 0.5 plus thickness of insulation is 0.4. Therefore 0.9 centimeter. Now we know the empirical formula for insulation resistance of a cable. So already derived in the last before class. Insulation resistance of a cable R is equal to rho by 2 pi L log base E R2 by R1. Right? Rho they given 5 into 10 power 12 divided by 2 pi multiplied by L 2000 log R2 0.9 divided by R1 0.5 base E, that is equal to 0.234 into 10 power 9 ohms. So that is equal to 234 mega ohms. Insulation resistance of a given problem is 234 mega ohms. So very important. Next problem. The length of the cable 1 kilometer, that is equal to 1000 meters, and a diameter of cable is 2.5 centimeter. with a resistivity of insulator is 4.5 into 10 power 14 ohm centimeter. Now find the insulation thickness. So the given length of the cable L is equal to 1 kilometer, that is equal to 1000 meter. The given insulation resistance capital R is equal to 495 mega ohm, that is equal to 495 into 10 power 6 ohm. Then conductor radius R1 is equal to diameter by 2, that is 2.5 by 2, that is equal to 1.25 centimeter. Resistivity rho is equal to 4.5 into 10 power 14 ohm centimeter, that may be converted into ohm meter, that is equal to 4.5 into 10 power 12 ohm meter. Before problem, they given resistivity, they given length, they given conductor radius, they given thickness of insulation, then we find out the insulation resistance. But this problem, they given insulation resistance, they given length, they given resistivity, they given R1, but they don't given R2. R2 is equal to R1 plus thickness of insulation. Now we have to find out that thickness of insulation. Therefore, let us consider R2 centimeter be the internal sheath radius, right? Capital R is equal to rho by 2 pi L log R2 by R1 base E. So we know the capital R value, insulation resistance value, that is equal to 495 into 10 power 6 equal to rho 4.5 into 10 power 12 divided by 2 pi into L 1000 log R2 by R1 base E. Now by adjusting the above expression, that is log R2 by R1 base E equal to 2 pi into 1000 into 495 into 10 power 6 divided by 4.5 into 10 power 12. By calculating the above expression with the help of calculator, so we are getting right hand side of that equation equal to 0.69. That means log R2 by R1 base E equal to 0.69. And now convert log base E into natural logarithm, that is base 10. So log base E equal to 2.3 log base 10, right? 2.3 log R2 by R1 base 10 is equal to 0.69. R2 by R1 is equal to, otherwise log R2 by R1 base 10 is equal to 0.69 by 23. Now R2 by R1 is equal to 10 power of 0.69 by 23. Otherwise R2 by R1 is equal to anti-logarithm of 0.69 by 2.3. That is equal to 2. So R2 is equal to 2R1. The given R1, that is 2.5 by 2, that is 1.25. Therefore R2 is equal to 2 into 1.25, that is equal to 2.5 centimeter. We know the R1, we know the R2. Generally R2 is equal to R1 plus thickness of insulation. Therefore thickness of insulation is equal to R2 minus R1. Thickness of insulation equal to small r2 minus small r1, that is equal to 2.5 minus 1.25, that is equal to 1.25 centimeter. Right? This is also an important problem. They given length, insulation resistance, conductor is small r1 and rho. From that we have to find out r2. Now thickness of insulation is nothing but r2 minus r1, right? Next problem. A single core cable has 5 km long, has an insulation resistance of 0.4 ohm, 4 mega ohm. Single core cable 5 km long, that is length of the cable. Small l is equal to 5 km, that is equal to 5000 meter. Insulation resistance capital R is equal to 0.4 mega ohm, that is equal to 0.4 into 10 power 6 ohm. Conductor radius small r1 is equal to core diameter 20 mm by 2. Small r1 is equal to 20 by 2, that is equal to 10 mm. Small r2 inter-sheath radius, that is given in 50 mm. So 50 by 2, that is 25 mm. Therefore insulation resistance of the cable capital R is equal to rho by 2 pi L log R2 by R1 base E. So substitute all the above values in the given expression. 0.4 into 10 power 6 is equal to rho by 2 pi into 5000 multiplied by log 20 by 10 base E. Now we have to calculate the rho value. Specific resistance or resistivity is equal to 13.72 into 10 power 9 ohm meter. 13.72 into 10 power 9 ohm meter. So like these three problems, 1, 2, 3. Out of these three problems, these three problems are very, very important. They are asking anyone without changing the values also, right? One problem directly calculate the insulation resistance. Another problem we have to calculate the thickness of insulation. Another one we have to calculate the rho value, right? Next problem, a single core cable has a conductor diameter of 1 centimeter and internal sheath diameter of 1.8 centimeter. If impregnated paper of relative permittivity 4 is used as the insulation, calculate the capacitance for 1 kilometer length of cable, right? Capacitance of single core cable, capacitance of a cable C is equal to epsilon r L by 41.4 into log capital D by small d by C. In the given problem, epsilon r is equal to 4, L is equal to 1000 meters, 1 kilometer length, that is L is equal to 1000 meters. Capital D is equal to 1.8 centimeter, small d equal to 1 centimeter. Now substitute all the values in the above capacitance expression. C is equal to 4 into 1000 by 41.4 into log 1.8 by 1 base 10 into 10 power minus 9 farad. Therefore, capacitance is equal to 0.378 into 10 power 6 farad, otherwise 0.378 microfarad. 0.378 microfarad. Like this, we have to calculate the capacitance of a single core cable. Calculate the capacitance and charging current of single core cable used on 3-phase 66 kV system. The cable is 1 kilometer long, having a core diameter of 10 centimeter and an impregnated paper insulation thickness is 7 centimeter. The relative permittivity of insulation may be taken as 4 and the supply at 50 Hz. So in this problem, you have to determine the capacitance of single core cable. C is equal to epsilon r L by 41.4 into log capital D by small d 10 power minus 9 farad. Another one, charging current. Charging current is equal to V phase by XC. XC is nothing but 1 by omega C. That is equal to 2 pi FC V phase. So you have to find out that one. First you have to calculate the C phase, right? C is equal to epsilon r L by 41.4 log d by d base 10 into 10 power minus 9 farad. Now we know from the given problem epsilon r is equal to 4, L is equal to 1000, D is equal to 10 centimeter, capital D, small d plus thickness of insulation, that is equal to 10 plus 2 into 7, 2 into 7, that is equal to 24 centimeter. Therefore, C is equal to 4 into 1000 divided by 41.4 into log 24 by 10 base 10 into 10 power minus 9 farad. Therefore, capacitance of a single core cable equal to 0.254 microfarad. Now, first of all, you have to determine the V phase value. They given, this is three-phase system, they given 66 kV. That's why that is a line voltage. To get in phase voltage, 66 kV by root 3, that is equal to 38.1 kV. Therefore, charging current V phase by XC, that is equal to 2 pi FC V phase, 2 pi into 50 into 0.254, that is the C value, into 10 power minus 6 microfarad, into V phase 38.1 into 10 cube amperes. So therefore, charging current is equal to 3.04 amperes. 3.04 amperes. Similarly, another problem. A 33 kV 50Hz three-phase underground cable, 4 km long, use 3 single core cables. Each of the conductor has diameter of 2.5 centimeter, and the radial thickness of insulation is 0.5. Determine the capacitance of the cable for phase, charging current for phase, total charging kVAR. Let us assume relative permittivity of insulation is 3. Therefore, capacitance of single core cable C phase is equal to epsilon r L by 41.4 log capital D by small d base E into 10 power minus 9 farad. Substituting all the values, C is equal to 3 into 4000 into 10 power minus 9 divided by 41.4 into log 3.5 by 2.5 base 10. Now, by calculating with calculator, we are getting C is equal to 1984 into 10 power minus 9 farad. 1984 into 10 power minus 9 farad. So, second one, total charging kVAR or charging voltage. Voltage V phase is equal to 33 into 10 cube by root 3, that is equal to 19.05 into 10 cube. Charging current IC is equal to 2 pi FC V phase, 2 pi into F50, that is equal to C 1984 into 10 power minus 9 V phase 19.05 into 10 cube. So by calculating this one, we are getting charging current per phase is equal to 11.87 amperes. And now after finding the charging current, we have to finding the total charging kVAR. Two pi FC V phase, 2 pi into 50 into 1984 into 10 power minus 9 into 19.05 into 10 cube, that is equal to 11.87 amperes. Now total charging kVAR is equal to 3VI, 3 into 19.05I and 11.84, that is equal to 67.5 kVA into 10 cube kVAR. Another problem, calculating the maximum stress and minimum stress. A 33 kV single core cable has a conductor diameter of 1 centimeter and a sheath of inside diameter 4 centimeter. Find the maximum and minimum stresses in the insulation. Where the maximum stress is occurred, there is the conductor. And then it will be goes on, reduces at the top of the cable. At the top of the cable, that is its sheath, the stresses are very minimum. Very minimum. So maximum stress may occur in the conductor surface, and that value may be decreasing goes on surface of the lead sheath. Therefore, maximum stress occurred in the conductor surface, minimum stress occurred in the lead sheath. Now you have to determine those two values. G maximum is equal to 2V by D into log capital D by small d base E, and V is equal to 33 kV RMS value, small d 1 centimeter, capital D 4 centimeters, they given. Therefore, G maximum is equal to 2 into 33 by 1 into log 4, that is 47.61 kV per centimeter RMS value. Then minimum stress occurred in the lead sheath. Therefore, G minimum is equal to 2V by capital D log capital D by small d, that is equal to 2 into 33 by 1 into log 4 base E kV per centimeter. 4 into 2 into 33 by 4 into log 4 base E, 11.9 kV per centimeter RMS. Right? Like that, we have to determine the G maximum value and G minimum value. And alternatively, we have the relation G maximum by G minimum. G maximum by G minimum is equal to capital D by small d. So from that expression also we have to determine G minimum is equal to G maximum 47.61 into 1 by 4, that is equal to 11.9 kV per centimeter of RMS. Another problem, the maximum and minimum stresses in the dielectric of a single core cable are 40 kV per centimeter RMS and 10 kV per centimeter RMS respectively. Maximum stress, that is the conductor. Minimum stress, that is the lead sheath. If the conductor diameter is 2 centimeter, find thickness of insulation and operating voltages. So conductor surface, that is G maximum is equal to 40 kV per centimeter, G minimum is equal to 10 kV per centimeter, small d is equal to 2 centimeter. Now find out the capital D. So we know the relation G maximum by G minimum is equal to capital D by small d. D is equal to G maximum by G minimum into small d. Therefore, D is equal to 40 by 10 into 2, that is equal to 8 centimeter. Now thickness of insulation, D minus D by 2, actually R2 minus R1, that is capital D minus small d, but this is a diameter, that is why by 2. 8 minus 2 by 2, that is equal to 3 centimeters. So G maximum is equal to 2 by small d log capital D by small d. From that, V is equal to G maximum into small d into log capital D by small d base E by 2, that is G maximum 40 into 2 log 4 base E by 2 kV, that is equal to 55.45 kV RMS. A single core cable for use on 11 kV 50 Hz system has a conductor area of 0.645 centimeter square and internal diameter of sheath is 2.18 centimeter. The permittivity of the dielectric is used in the cable is 3.5. Now find first one, maximum electric stresses in the cable, minimum electrical stresses in the cable, capacitance of the cable per kilometer length, charging current. So area of cross section A is equal to 0.645 centimeters square. We know that pi by 4 d square. Area of cable is nothing but pi by 4 d square is equal to. Therefore, d is equal to square root of 4a by pi. That is square root of 4 into a 0.645 divided by pi. That is equal to 0.906 centimeter. That is the diameter of the conductor. Now capital D, diameter of the sheath. They given 2.18 centimeter. Therefore, maximum electric stresses occurred in the cable is nothing but conductor. That is equal to G maximum is equal to 2V by small d log capital D by small d. So 2 into 11 by 0.906 into log 2.18 by 0.906 base E, that is equal to 27.65 kV per centimeter RMS value. Now minimum G maximum is equal to 2V by capital D into log capital D by small d. 2 into 11 by 2.18 log 2.18 by 0.906 base C kV per centimeter. That is equal to 11.5 kV per centimeter. Last capacitance of single core cable is C is equal to epsilon r L divided by 41.4 log capital D by small d base 10 is equal to C is equal to 3.5 into 1000 by 41.4 log 2.18 by 0.906 into 10 power minus 9. That is equal to 0.22 into 10 power minus 6 farad. So charging current IC is equal to V by XC, that is equal to V by 1 by omega C, that is equal to V omega C. Omega means 2 pi F. So V 2 pi F CV 2 pi F 50 C 0.22 into 10 power minus 6 into V 11,000. Therefore, after calculating the above expression, we are getting charging current IC is equal to 0.76 amperes. So like that, you have to determine the problems: insulation resistance, single core cable, electric stress maximum on the conductor and surface, thickness of insulation, right? Thank you. Thank you one and all. So next class we discuss about the remaining problems, that is problems on 3-core cable, inter-sheath grading, right? Thank you one and all. To see this video, please subscribe DBS Talks.